All right, should be up again. Get the chats up. So, yeah, last stream that I did yesterday evening got a copyright strike for me typing on my keyboard, which is hilarious. Looks like they're gonna fix it though, but like I don't know how this anything works anymore. Anyway, yeah, so last night I got all the DCP initialization done, and the next thing to do is to get some buffer swaps going. The main thing about that is that there is a big structure that is used for that. Actually, here's an interesting one. There's a swap complete intent gated thing that I'm gonna have to implement, but right now we don't get the callback from that. And this is all this DCP stuff I want to do, but I know how this serialization format works, but I'm more interested in the swaps first, so I'll leave that for later because it's not critical. But this, I'm kind of interested in why this swap complete. Oh, it's probably because of there was a power down involved, and like yeah, but we do need to implement that function later anyway because I believe we do actually get that. Oh, we get swap complete AP gated is what we get, so that one definitely needs to happen. And for some reason that one has like IO arguments. No, those are. It's an input pointer for subcompleted, and then a swap info blob. So that's kind of backwards because for some reason it's printing the input and the output side too. Yeah, I think I broke that with that refactor yesterday. The part where here in print long args basically it'll be if name in invals and outvals yeah, there we go. It doesn't print that every time. So this callback obviously needs to be implemented, but it's all input arguments, so that's fine. I can just and this is on I will learn buffer AP. I don't know what these are. And arc 2 and 3 are the weird ones, so just print that in here and I wonder what those arguments are. The indentation there is weird. Okay. So that's I think the only callback we care about, and then the actual swaps we need to happen are There's a lot of stuff. Let's go to the end, which is more interesting. Actually, no. Let's go to the first one. Yeah, here we go. So the very first time it happens, we have to do a swap start. I don't know what that is. So let's do the init stuff. We did the start signal, and that all finished. So then the next things that need to happen are looking for calls. Ignore the power saving stuff. I don't know about that notify clients thing. Might as well call it just to see if anything interesting happens. And it looks like it just adds them, so it's probably just like you just do it once. It'll be, and those look like bools, to be honest. So let's switch that to a bool. It says it's an array of uints though, but what was the original thing there? So we do have the, yeah, it says it's an unsigned int, but it looks like bools to me. Anyway, yeah, bools will be serialized differently though, so I guess we can't do that. So it'll be 6 zeros, 3 ones, 1 0, 1 1 1. We'll find out what that does in the future, I guess. Then we need first client open. Might need a set power state. I don't know if we need this, but okay. Once it all works, then we can start messing with these things and see what changes. I also don't know what this says. I probably don't want to do set digital out mode because I get the feeling that's going to do a ton of crap. So I'm going to skip that one. And it does set this with device 2 again, so it is the same parameter again, and then another digital out mode. Then it does a get gamma table, which is apparently all zeros anyway. Set contrast 0. Set brightness correction. Oh, and now we know what that is. Interesting. So that we know the prop relay properties 14 is brightness correction. I should start making notes of those. What's a good place for that? Probably in here somewhere. Where's my find then continuum? I have one of those somewhere. Should be in base. No, in DCP. Yeah, this. So let's do set display device, parameter DCP, same thing as before. Another digital mode. Yeah, it thrashes a lot. And there we go. And there goes the swap start. That's the first one. So let's go to the DCP. And does that take any arguments? Yeah, 0, and then a container of stuff, which for some reason is in out, even though it shouldn't be. This looks like bullshit though, because that address, I mean, it's a kernel address, but DCP doesn't care about. So let's just copy and paste this one and then find out if anything, if it matters. Probably doesn't. And what was this called actually? Because I know we have a name for that structure. IO user client. Yeah. So this is actually representing like a user space client of the DCP, which doesn't really matter, does it? What keyboard do I have? It's a Philco Majest Touch 2, Japanese layout, Cherry MX Brown switches. Nothing particularly fancy, just just a very plain MX Brown keyboard. So swap start, set matrix. Interesting. What is so? Those are what values are those? They're just a big, yeah. It's like I guess, probably a 64-bit thing. So we can then mess with this later and see if we can change the colors just to prove that everything works. And then there's a swap set color matrix, which is interesting. Actually, I wanted to figure out what this structure is, because it's kind of weird. Let me do a little quick. So basically, we have 1, 2, 3, 4, 5, 6, 7, 8. Let's do it as 32-bit values here. It's basically that. That should be the whole thing. And so, but assuming this is a matrix that is is a identity matrix, then that means that this actually should be something like it should be more like this, right? Yeah, so like that kind of makes sense, but then I wonder what the first and the last lines are. And also, that's kind of back. No, it's not actually. This is fine. Yeah, so it'd be 64 bits. So if it's the same format as this, then this makes sense. But then I wonder, like, what's this about the beginning and the end? Which is kind of strange. So I don't know what that is, but let's make it a struct though. Actually, we can just do it as an array of. I mean, this is probably wrong, but let's just do it as an array of. Let's do it like that. And that's probably close enough. Or not. Num. Yeah, that makes sense. Not the nicest display, but better than a hex dump. And that is an in-out pointer for some reason, which is probably just a mistake. Should probably just be in. Then parent 3 to 1. I'm not going to call that even though, so it probably doesn't matter. And then there's a set block DCP. I don't know what these do. These are kind of interesting. And I think I think these are floats most likely. Yeah, see, that's 1 in floating point. And then like 3FFBO2 is probably, yeah. Wonder if that's some interesting constant. 3D80. Interesting. 3D64. C16A. So this might have to do with color correction or something. I wonder if this number is Googleable. Probably not, but just in case it's some kind of standard matrix. That's interesting. The negative. They actually had a hit for the negative, but this looks unrelated. Okay. Yeah, so I'm going to skip those. We don't know what these parameters are. Six gets set to 1, 2. I mean, those numbers actually look a lot like brightness and contrast because that would be, as a 32-bit value, this would be 1, fixed point 16.16, that would be 1. And that also makes sense with the set brightness correction stuff, so I wouldn't be surprised at all if those are color constants. And then this set block DCP stuff is quite likely related to color correction, but it's hard to say. So I'm going to skip that for now to see if we can get some swaps. And then it does a swap submit DCP, and that's really all there is to it. So that's the interesting bit. And I think this is setting a 0 surface. Oh, that's interesting. Yeah, that's actually a bug in my utils. ASCII is... Why is 7F passing this? Huh? Oh, no, this is a bug in construct. Not my hexdump, theirs. I should file that. Yeah, DCP supports modifying the gamma ramps. It's in there somewhere. There's a gamma table thing. It should have all of that. So, yeah, I need to figure out what these structures are. So what I can try to do is just use these as is for now. And these A's, by the way, I think are padding. Like uninitialized data ends up as that. And then slowly figure out what's going on here. So let's copy and paste this. And then we can figure out if this starts to make sense. So let's do swap rec equals on hex. I need to add the padding for these things here. 89A, that's fine. And then EF1 and 1, 2. Well, this needs a whole bunch of stuff. That's going to be really annoying, isn't it? wonder if this is like another. Yeah. Do we have the swap reg get more stuff at the end when we are actually showing images? Not really. It's mostly. Actually, sometimes it doesn't even go beyond that. Yeah, sometimes it even stops at 120. So this just has like a little flag there, actually. Okay, so actually, how about I do it like this? Um, let's do it by taking the first 120 bytes as is, and then figure out how to put that extra one in there. So, what's the best way of handling this? I'm gonna figure out like what the nicest way to mess with this later is gonna be. Let's do it like this first. So that's up to 120. Up to 110. Yeah, so 120. Sorry, that's up to 120 with the FF there. And then we would need like that. And then just add this. And then it's like 320 bytes actually. To E0. This will become a struct later, but for now, something since I know what the fields are. And there should be 320 bytes. And I think this is a null swap. I think this is swapping to a black screen because I think this array is the surface addresses and it's 0. So in theory, if this works and it doesn't crash, I should just get a black screen. If I'm right about this. So about the surfaces would be a list with just one. Let's just do a surf first. And that one is actually complete. There's no anything else. So let's just take off the junk. Those should be nulls. And then finally, it'll just be mgr dot swap submit DCP with these arguments. And then I need an okay. And then we want to wait for swap. Well, at this point, we might as well just get a shell. I can make a thing here so we can wait for swap completes. And swap complete should actually have like a frame number or something. Because it gets swap complete, say 13, 15, 16, 17. Yes, that has like a frame number. And I actually don't know if that gets passed in the swap or not. It might. Definitely not there. It's not a return either. Yeah, so it's probably just an internal frame number. But there's got to be some kind of record here that tells it which one was like here. Also, there's, by the way, like a shared memory area where like the current frame gets stored or something like that. I'm not sure what that is about too, but there's a thing. There's not that much going on here. There's an A, which just looks like the frame number, but yeah, that's the frame number, all right. I just kind of wonder if there's anything that's sort of tying this to the swap that actually happened. Ah, there we go. OFDA 886B is a thing. Yeah, so this actually gets passed here, so whatever that is probably some kind of ID. Or it could be a timestamp, I don't know. Yeah. So that's good to know. But anyway, let's just do and the frame is probably arg0. So then basically I can just do a thing where okay, so let's do something like that and see what happens. And at this point, I'm going to need to have my output open because this is going to be useful. And in fact, when we put this window here, and let's run it and see what happens. Though I think at this, I need to reboot, yeah. I was doing stuff already. Okay, assertion error. Interesting. Is instance val by ref set power state? Okay, set power state is. Oh, it's an out pointer. Okay, yeah. I don't actually care about that. So. Okay, swap rec is not 320. Why? Oh, sorry. That's not right. FF 110. That should be 120, and then 2C0 1 2D0. Sorry. Okay. Depth building bytes value per hex Unicode. There's not like the nuns. It's the nulls there, but is that build? Just make sure that's the issue. Okay. Also, that's not right? But yes, it doesn't like the nuns. I need to implement that properly here in IPC. This is an array of in pointers IO surface. Yeah, so then that ducks the null and then does the zip, and then in building I need to do the opposite thing. Yeah, so here basically I need to do something here. So if V is none, then I need to just pad it with junk, which probably the easiest way to do is to do basically yeah. Probably the easiest way to do that is to just do V equals field. Just fill it with whatever V zeros. Uh-huh. Almost, but not quite. See, why are they all zeros in this case? That's kind of weird. That's kind of weird. It's a none, but then it gets a... Why is the first one all zeros? Whoa, what just happened here? This is weird. Am I doing something dumb here? Why is it appending a whole list container of stuff? Oh, because this is the whole field. It's not field. It's field.subcon.parse or something. Which is the array. Well, actually, I can just do field parse. I can just do like this. And then I can just do val equals. And that will probably work. Okay. It failed the swap and swap submit lost. Okay. Why? Oh, I bet I know why. I bet it's because of the timing issue. I bet it's because this probably has a timestamp where the swap should happen, and then if you do it too late, it or something like that. If you do it too late, then it says nah. There was a timestamp thing going on that I think I haven't seen yet. The like get current time. Like that looks interesting. So there's a swap ID 10, which there's a 0A there, so that might be the swap ID. Okay. What about swap start? Does that return an ID? No, this returns 0 every time. One second, just gonna use the toilet. Okay. So, let's see. Submit last. Yeah, I don't know why that fails. So what if I change? I'm pretty sure that's the sub ID. Yep, obviously. So let's start making. Actually, I'm gonna add a thing to my unhex thing that is gonna be useful. Actually, yeah. How do I do that? I think that's the. I think that works. Nope. That did not actually work. Did I get that right? No, I did not. Pattern replacement string. Okay, that makes more sense. Yes. So what is this in here? Sub loss, submit loss, enable, complete it. Yeah. It doesn't tell us why. Doesn't really tell us anything. And these numbers, what are these numbers? Yeah, those are just like. I don't know what those are. Ends in 483. Yeah, it's the same numbers every time, so I don't think it's a timestamp thing. Wonder if we need those set block DCPs. kind of wonder if any of this data has to come from somewhere else. Yeah, it seems to like it shows up there eventually with an address. Let me open this up in another window. And I can compare both that way. Ooh. Yeah, so you can see some numbers increasing. And there's a 7-7 at the bottom, and then it becomes 1-1, and I think it's 1-1 every time after that. And then we get a 5 there. B6B, 6B, 8. Just make sure that looks good. Yeah. Yeah, the structure is in the right place. That looks weird. The 80. That's weird though. Why is that like start the same? 3, 4, and then oh no, that's a truncated message. Okay, that's why. It's just a stupid syslog truncates messages. So it's that's the real one. So yeah, there's it's 0 something 07. Is that a thing here? Yeah, there. Okay, so that actually makes sense. So that's probably these things here. So in that case, the ones that so 7 probably means they're swapping all 3 of the that's why the next one only does 1, because it only swaps the. And I just have as a 0 there. So it so let's try setting this to just swap the 1. Maybe something else needs to happen. Yeah, without the comments. Damn it. Okay, that still fails. But now it's 1-1, so at least I know what those are. And there's no more message, so probably missing some setup that is required. So this is after that. Probably don't need this one, but might as well call it. I might need set digital out mode, to be honest. 8638. And then it starts swapping. Whoa, hold on. What just happened here? Why did arg0... Huh? Oh, is that... Right, okay, so the swap ID gets returned by... Sorry, I'm dumb. Yeah. It is... Okay. So it does return a swap ID, and then the other one is an input pointer, probably. Okay, so that's why, probably. I'm going to comment out these because I expect that to be annoying and probably not the problem. So what I'm actually getting for swap start... Wait, am I not doing swap start? Yeah, I am. It's here. And then swap ID needs to go in here. Eventually this has to be a struct, but Do I want to do a little cheat here? This is horrible, but it'll probably work. Uh, oh. Uh-huh. It crashed. Oh, Axie read error. Okay. 40310600. Am I actually swapping into something then? It might be that there's a frame buffer. Yeah, 4031. No, actually, it isn't. Is that somewhere else? It looks like a Dart address, all right. But it might be something else. Wait, 4031. Is that MMIO? Int handler gated. Fader. Axie read error. 4031. This is swap ID thing is correct. Let's print that out too. I'm dumb. Oh, it didn't that, yeah. 40310600. Is that a thing? No. It's always 40310600. Let's see. I think we're getting pretty close. But I wonder about that. Almost looks like it should be MMIO. 4031. Hold on. Nope. And it looks like a Dart address. 40310600. They don't actually mean the. Let me just dump the Dart on that. Ooh. $40.31. Yeah, no, that's totally. No, sorry, that's the wrong. No, it's the top four, so it should not exist. Yeah. And we do map the what? 40310600. The thing is that number doesn't really come from anywhere as far as I can tell, which is a bit annoying. Yeah. Forty 31. What is that? It'd be nice to get a proper backtrace from this, but I do have the firmware here. Oh, this is an old version, but XC RDR doesn't even show up. No. It's not even in the in that maybe it changed in the new firmware. Let me see if I find that string in the actual extension or something. To go to the yeah, that is in there. I actually load that properly. I think I did. Yeah, probably fine. Yeah, this thing. Wonder if it's actually, hold on. Could be in here. Doesn't look like it though. Nah, doesn't look like it. Still analyzing on that. I'm kind of curious to see if this actually in the yeah, it is in there actually. This is the this is the non-firmware version of that, so it's probably worth throwing it in here and taking a quick look at it. Uh, see if it finds any references to that. Might be useful. Meanwhile, still very confused by what that address is. Is it from the display dart? It could be actually. But in that case, I should dump that. Could be that it fails reading from the display dart, but because maybe that's an error that is an error returned from the display controller. So 40310600 could be a display controller dart address. And yeah, there's nothing there. Is this right? I think so. The frame buffer is where? 9 EOCB8. Yeah, this is the frame buffer, obviously. 429C0. I do this. So if I set it to all zeros, it actually does not like it. Yeah, so it looks like that's just an interrupt coming from something. And given what's going on here, that looks like it's an error from the display controller. Yeah, and there's the swap request complete, right? When it actually completes. Yeah. So it's clearly an error from the display controller, which means it's probably an address that is so maybe that's actually coming from not having called some of the swap start stuff. Some of the set parameter DCP things. Maybe set block DCP. Are there any that look like addresses? Also look like floating point numbers. Pretty much. Yeah, those just look like floating point numbers. What is that big number anyway? Some kernel address. That probably also doesn't make any sense. It's probably just the client or something. C10. Yeah, I don't know. That's probably just bullshit. So what I'm going to do now is run it again. Let it crash, and then shell. So what was that address with the frame buffer stuff that we don't actually have in the ADT? That didn't work. That also didn't work. What about that one? Okay. Nothing interesting there. What about here? Nothing interesting there. Nothing there. That doesn't look terribly interesting either. I wonder what that is. Nothing there. And that one has a lot of junk. Wonder what that is. But we know there is a... Actually, what about the Dart? Is there anything interesting in the Dart? Because that has some error registers. I think some of them might be shifted, so it might be hard to see, but... It's 40310600. Hard to see. Can't really say much there. Okay, so what was there was that silly register in there's display registers we don't know about, and one of them was referenced in the Corellium preloader. What was that? No, we don't have that. Let me just Google it. Like they used they had a register in there for changing the frame buffer. The frame buffer thing. I used it like when I was explaining how the hypervisor stuff worked, and I forgot. Yeah, that one, which I think we didn't have here. So it should be there. 20385. 3085. Yeah, that's not in the list for some reason. So that's I think one of the registers that DCP would mess with. So let's try reading from that. A lot of interesting stuff there. Okay. And see, this is obviously a like a gamma table, right? Oh, by the way, did we actually do break it while doing the swap? Probably, actually. Let me just do this again. Reboot. Yeah, okay, so it actually does break the display when the swap at least. 4031 600. Just run the shell at the registers. There might be more stuff here actually. Not quite. EC 085. Actually, where does it get that info from? Is a good question. Let's put stuff in the stack, and where's the other thing? SDP, so X8 probably from X22. That's the French is 0. Where's that coming from? Oh, it's just this. Let's see, read error. Oh wait, W32 actually. Or not. Could be actually. That's the same thing actually. Register stream read. It should be this thing, to be honest. 22, maybe? No, it's just this again. Four, 6, 1, 8, 8. Yeah, I'm not sure where that is. This looks like it's a pretty complicated piece of hardware, to be honest. With like, they probably have like an automation for writing registers and things like that. I really wonder what. Okay, so I have an idea. I have an idea. I'm gonna put this in a regmon. Huh? Okay, we can't touch that, but we can touch 44, I think. Yeah. Let's just read a bit of everything, see what changes. I don't know what's going on there. Did I just kill it? Yeah, it did. Oh, yeah, duh. That's just pretty much all zeros, isn't it? Yeah. Yeah, that killed it. 4, 4, that's a 4, and then there's 1000 here. That's probably other stuff, though. 3B73. See, that's also this spec 0, so it doesn't make any sense. Yeah, so the DBD is also common. Yeah, so the ones that matter are these at the beginning there. Yeah, obviously. 30. Uh, uh. Let me do a little memory dump of this, actually. I have a... I'm pretty sure I have a thing. Not mem dump, it was a... maybe not. Address dump, yeah, I think that's what it was. Do a quick thing here. And in this case, what I actually want to look at is basically this. 3.8. So basically, it's going to start at 0, 0. Like that, 2300, and it'll go until 232. And all of that is potentially start. No, sorry, disp. And but I only want to look at, let's say, page-wise. Okay, so we can see stuff. I need to make that as not verbose. How do I do that? Forgot about that. Yeah, hold on. Yeah, that. No. Oh, just we're still using tabs. Why is that not working? And also, it's probably going to the frame buffer, which is why it's slow as hell. Where's that thing? Turn it off. Yeah, that. Let's turn that off. Thank you very much. I don't know why the guard thing isn't working, though. I think it is maybe that read32 was implicitly doing that in the proxy. Yeah, it doesn't use more guard marks. This is kind of pointless. Let's just write to a file. Oh, I've broken something. I need to reboot. No, there's stuff there. Okay, cool. So these are the ranges that we can actually read. And I can kind of tell what the interesting ones are. So let's see. Go to DCP. Actually, I should kill Discord. Let's see. That may or may not be interesting. It probably isn't, actually, but... Actually, 1.8, let's see, 1.8, yeah, it only goes to 1C there. And then, at 6.8. At B0, another 2 pages, maybe. At F0, there might be something interesting. And then at 1, probably this about this much. At 7, looks like there's also about that much there. Sorry, 1.7. And then at 1.8, there's some stuff too. I wonder what that is. It's kind of interesting. At 1A, there's also some interesting-ish things. Let's just do that much there. 1D, there's 1 page of stuff. And then we got 23. I don't know what that is, but probably worth doing about 4 pages there. And then at 3.8c, there's something. I don't know what that interesting. It's like, this is like color values actually. This pretty much looks like RGB values. It might be a palette even or something. Or like a dump of something in memory. And 2308, there's things. Let's just do another 4 pages there. This is going to be super slow, but then at 8.5 and oh, interesting. I didn't see anything there, but yeah, 8.4 might be interesting. It's got only 3 pages there. At 8.5, can definitely do this much there. Actually, twice that. At 70. At 80, there's something. 8. 2 pages, maybe. At 9.4. There's 1 page, I guess. I'm kind of assuming that the alignments here. A8, AC. Maybe 2 pages. B0. Again, maybe 2 pages. And then it goes to F0. Another 2 pages there. And then, oh, hold on. 8 F0. Did I just, 8.9.4, sorry. Offset here. Eight F0. Oh no, A0 is just 4, and then it's just AFC is another page. Then 9.0. It's at least this much. And it also looks like more colors again. There's stuff at 9.7. Let's just do 4 pages there. 9.8 looks like more colors again. 9A might be interesting. Nine D has something. A3. And then we go to B8. At But again, it looks like another color table, B8C. And here's something interesting at 10C0. And on 313. One 192. 196. 197. 1C. Maybe that's good enough. And what was the one we were just looking at earlier there? 23085. Yeah, we have that. Okay. This is probably gonna explode. uh, ah. I am on mon. Save. Okay, definitely got some exceptions. I need to clean up some things there. Also, I don't need to dump the Dart anymore. That's a lot of junk I don't need. Okay, those are obviously colors or something. Let's see what happened here. Okay, that's a lot of junk. Not interesting registers. 230 is, yeah, I don't know what that is, but it's clearly not useful. Looks like just garbage. 18 has stuff though. One 8. There's one page there. Then 6.8. Also, it's not useful. Is that just a mirror of the same thing? 3904. No. It like ends there, which is interesting. I wonder what this is. It's kind of interesting. And then these actually do look like colors or something like that in the. Because I'm not sure actually. Not quite. They're close. And there were some errors. That one failed at F4. Okay, so that doesn't work. Well, it failed once and then continued though, which is weird. Oh, it's probably then just that bullshit copy then, yeah. So F4 doesn't work, okay. But F5 kinda does. Unless that's from before. No, that's from before, yeah, that's just junk from before. And then at 1.0 it does work. Any other failures? Ah, there we go. 19C doesn't work. And look for more exceptions. At 1BC. What? Hold on. 31BC000. 31BC. Why? Where'd that come from? 3118? Ah, here. 31BC000. Why is it there? Where'd that come from? Okay, there we go. So where did the C1BC come from? 3118? 1BC. Yeah, okay. That's what I wanted. Yeah, makes more sense. So let's run that again and see if anything changes. Should see what the DCP is doing at least. Should be interesting. Did I just break DCP by doing those reads? I might have. Actually, yeah. Okay, so let's binary search this. Okay, that works. Interesting, a lot of things changed there. Actually, where is the DCP? That was 3130. Okay, so that's the Dart is here for one. That's just the Dart, so. And the DCP itself is at 31C. So that, and then 3185 is something. Okay, no, it still breaks though. Damn it. Nope. Okay, that works. Let's add those two back in. Okay, one of those breaks it, so comment those out. Okay. Nope. So something else here is also breaking. Maybe this one. Nope. Ah, let's do it too quickly. No. That one too. Okay. Okay. Okay, that one breaks it. Make sure that it still works. Yeah. Let's do that one. And that breaks DCP. That also breaks DCP. I think this whole end section is DCP itself. Yeah, probably. Okay. Oops. Okay, so let's run it with that and see what changes. There we go. So the interesting thing here is it does we're doing the polls right before swap start, I think. We don't know what the DCP stands for, but I'm assuming it means display control processor. Okay, so here's some interesting stuff. I can see what registers change in the DCP over time. So After the init, a bunch of things changed. So there's a lot of things here that changed in 8FE000. Okay, that just looks like it changes every time, basically. Actually, that looks like a histogram. Like black and then, yeah. This kind of looks like a histogram. And then there's like a big, yeah. 8FE00. I'm pretty sure that's a histogram. Because that would be, the number of black pixels. Just probably close to, it's probably close to, yeah, interesting. Okay, so now we know what that is. See, we're gonna find interesting things like this. That's a histogram, so obviously I don't care about that. 8FE FC. So FC is probably, see, when after the swap it goes to zeros except for like it got pink, right? So it's RGB, right? So the histogram for the red is all on, the G is all off, and then yeah, 1FA400 is everything, right? Yep. These are registers. So these are the display controller registers that I want to see what DCP is doing, because the problem I have now is the display controller is throwing a memory access exception because it's trying to access something that it doesn't have access to, but I don't know why it's doing that. So I'm seeing if I can see in the registers where that address is, and if there's something that I need to do to DCP to clear it. But yeah, this is interesting. So FC, yeah, FC is actually. So we can get rid of that. See, this is cool though. There's a histogram here. So that's something we can ignore. Then a lot of things change here, and like A5 2. I don't know what this is. This is also looks like gamma table-ish. But does it change every time? It just gets set once, I think. After a subsubmit DCP. Yeah. 852. It's like a big table. But 8.6 is interesting, so do that separately. I don't think it's HTTP related because they do HTTP in the SEP. There's a SEP thing going on, so I think the actual like key management is done in the SEP. Okay. That's much more manageable. It's a much more manageable number of register changes. Cool. So the thing that failed is address. Oh wait, swap complete. Sorry, I need to do that, and then it died, and then stuff happened. Okay. So this failed on 431. Is this address somewhere? Yes, it's here. But this might just be the this might just be the error registers. Isn't that the that Corellium thing? 23085, yeah, 45. So it's pretty close. It's pretty close to the main display controller registers. Wait, hold on. What? 230850. Huh? Wait, hold on. Is the gamma curve like after the registers? I'm confused. No, where's the big gamma curve now? That's not the right place. This 86 is a big curve. Sorry, not 5. I think. Okay. No, there's another curve there, but these are where exactly? Oh, it starts at 852, that's why. So this just needs to be 2, that's why. And then 86 has more of that, I think. Let's just turn that on. There's the DCP support DDC. Yes, there's DDC stuff in there. There's more at 5. Yeah, so it goes to 5.2 to 5.6 pretty much, and then that's it. Since when is the Asahi logo rotating? What do you mean rotating? Okay, I think we're good there. Yeah. Oh, this is a dart. I can tell this is a dart. At 231302, that's a dart, obviously. Because these are TLBs. Well, that keeps changing. Interesting. One 7C. That's some kind of time thing. I wonder what these registers are. So 403106. Right after the swap. And then it crashes. So let's see about that. I'm going to clear the screen and do it again. Damn it. Well, that also clears the screen. So let's run it again. And I need like one more work for it to... Yeah, so that's where the 4031 thing happened. And those came out from 0, so... Those look like report registers. One. Yeah, it's pretty much just those. Oh, 6, oh, 40, oh, so this, oh, 40 and 0600. It's almost like it's at 0400. So what is that? Just a guess. Uh, 845860. Oh, whoa. That's the DCP heap. Oh, come on. What? No. No, wrong. That's just a. It's not. Hold on. Different offset. Sorry, I was really confused there. Hmm. I was reading from there too. Okay, so what if I just give it stuff? Um, I don't know what that is, but if I just say, I always forget the argument order here. Stream address size. I'm up at. Sorry, that's what I need. Uh, yes, the coprocessor firmwares are assigned. I think it didn't crash this time. Oh, plane height is smaller than the source direct height. Okay, so there's another issue now. But indeed, something is accessing 4031, and then it failed. I hate how the syslogs get truncated. So where's 824? 338. Here, 3803. Is that something I touched? So this is already offset, which is kind of annoying. Yeah. These are packed structure. I know that. It's kind of annoying. $780. Okay, so that's 1920 by 824Y. Is that something I touched previously? Probably. Didn't I touch that before? Probably. Hold on. Uh, Oh yeah, 438. Hold on. Okay, that still fails, but now where? 431. Okay, so it isn't. Even if I map it, it still isn't like it. 40310600. Though I wonder what stream that's supposed to be mapped at. It might be the wrong one. Let's dump the whole Dart and see. Also, I don't know if I need to invalidate for these things. I don't think so. Oh, it should just be. So the stuff mapped at dev 0, but then also at dev 1, 2, and 3 actually are there, but have no translation tables. And then dev 4 has some stuff. Let's do one for dev 4 just in case. Unless that means like that 4 is actually something else, and it's actually. Well, that could be actually. Pink is the color that it reads when it can't read the data from memory. Oh wait, that might not be the address. That might just be like a stupid code or something. And then maybe I'm just dumb. Can I get the read error address from the Dart? I think Sven had that stuff somewhere. Uh, 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 uh. Dart error. Let me add those to this. Oh, we do have the error ones there. Error. Right fault. Right fault. Let's add that one too. Okay, let's see what happens if I just dump those. I might just be very confused as to how that message works. So Dart DCP. So before the swap, if I do pull and then a this start dot there's regs, I think. Yeah. Is that just dot dump? Dump regs, yeah. And then after the submit, let's do one more. Oh, okay. Aha, error address low. Okay, so it is a different thing. Or no? No, it's not at all 0 anyway. And where did it die? It died doing dump regs. Why? 60? Wait, I can't even read the config register? Or did I get that size wrong? Oh, register 32 probably, sorry. Dart. Yeah, that would explain that. Okay, there we go. So now, aha, 7E. Okay. It's no PMD on stream 0. 7E. Okay. So that's a different thing. And that happened after the swap. Yeah, it was previously had no flags. And then after the swap, we failed to read at 7E0000. What is that? Is that... Oh, is it just reading from 0? Oh, maybe it is setting up. Maybe it is setting up a frame 0 and it's just expected to be at address 0 in the. That could be it. Hold on. Want to face 7E? No, but yeah, maybe it's something like that. Okay, so let me map it to there and see what happens. Oh, that broke interestingly. Not quite. Oh no, it completed. Soft complete AP gated. Okay, it this time it didn't crash. At least not immediately, anyway. Even though it's still pink. Where's manager soft complete AP gated? Keep reading the self in these. Okay, so yeah. I don't know where that address comes from, but it's obviously coming from somewhere, and it is 7E. Cool. It didn't crash. And it didn't fail. The address looks like that. It looks okay. So I don't know why it's pink now, but it's not failing to read memory at least. So where's that coming from? So I don't see 7E coming from anywhere. It might be shifted though. Now, the interesting thing is that I mapped 1 megabyte, but the frame buffer is more than that, right? Yeah. So this isn't the frame buffer. This is something else. So what is in there actually? There's a buff. I have a buff. It doesn't actually read error though. It's just zeros. Yeah, it's just empty. Nothing really happens. Yeah. So I don't know why it's reading from there, but it might be something that gets left over that I need to set. Like it needs some information there for some reason. Oh, oh, okay. So we have something there. That's interesting. So is this like a color table or something? Or is it like a map? Okay, and you get a black bar at the bottom. Okay, so it actually crashed at that point. Interesting. And now what? So is this an indirection table somehow? Now what address is 7F works. It's moved to 32. Okay, that's quite interesting. Ooh. Wait, is this the mouse cursor or something like that? Is this some kind of like tiny little... No, but still, this is... Okay. Then it goes to yellow. Okay, so this is something. Why is 7F anyway? And then you get like the weird color at the bottom. Okay, let's reboot again. Set to all zeros. See if it crashes. I'm going to turn off the register monitor because this is being very annoying. I don't think I need any of this anymore. Did we crash anything? No, we didn't crash anything yet. So if I mem set it to 7Fs, which was the interesting black one, then it crashes. Then it crashes reading what? Nine. But no, actually, it didn't crash. What's the crash? This isn't actually read error, but the Dart their registers don't say anything. That's kind of interesting. Unless it's just that by changing this, I've broken something. So what if I do the mem set here? And then do everything. Okay, did it crash this time? Yes. And the registers this time... Ah. No, it doesn't really have. Hold on. Nothing there. String 9404 AD, then it crashes after you submit DCP, and then it's 24 AD. It's the same though. Okay, so I think what must be happening now is that this is actually making it read somewhere where it doesn't even hit the dart. Okay, so set it to 1, see what happens. And I kind of want to bring back at least the error registers just to see what's going on there. Which are these 230845 something. Is that completed and didn't fail? Now it crashed. I can tell because of that. Yeah. If I go 860. Still no error though, so Okay, let me just snoop on those registers, on the error ones. Just make it more obvious when I break it, which is here. Okay, let's reboot that and see what values make it die. Doesn't do it. Interesting, so that doesn't crash it. That does. Okay. Interesting. Is that gonna work? That still crashed. Oh, it does happen. Yeah, okay, so those black ones cause errors. So these don't actually cause errors on the Okay, so what about okay. So this is definitely a buffer of some sort. Okay. Oh, and it's tiled. It's also scrolled. Okay, this is cute. Now I have an idea. feel like if the bottom bits are 0, then it just sets everything to 0. Okay, there's some kind of color going on here. Clearly. Yeah, this is a color. Obviously. Ooh, and now something interesting happened. Oh, I have an idea. Is this like a compression format or something like that? This might be like a compressed frame buffer. I still don't know why it's here, but that might explain why it's behaving interestingly like this. So why don't I allocate more than that? 16 megabytes should be enough, hopefully. Well, not like PNG. That's not the kind of compression that frame buffers use, but they have a thing, yes. It's actually used to save memory bandwidth so that it. Okay, so that did kill it, even though I still don't get any. Still don't get any errors, which I don't understand. That does have one that claims to be stream 1, but that might just be bullshit. I do know the darts tend to hmm. I think the buffer doesn't have to be much bigger in this case. Okay. See, this compression thing actually explains why the screen is pink even though it's not throwing an error. because it might mean that that the compression says there are no pixels, so like the format is wrong, but it's not an memory access error, so it doesn't crash. Actually, let me see if what I just did there, that one specific line crashes it. It does. Interesting. Yeah, it's that tying format. And I think the colors might be later. Like these are like tile descriptors or something like that. And there's more stuff going on later. It might be that like there's pointers involved or something like that. And then there's like maybe interesting. Did I just kill it? I might have killed it. Is it possible to dump a screenshot from booted OS X and insert it here? In principle, yes, if I figure out where the frame buffer lives. I still don't know where the 7E comes from. I mean, it should be here somewhere, you'd think, but... Unless... it's just that it's not being reset, which could be it. I did complete the swap. Hold on, so what if I disable that? Reboot. Get a bit more there. Oh. Oh. That is an address, and it's shifted. So maybe it's if I set 0, it just uses the previous address? But then I don't know where it comes from. That's weird. Okay, so let me do it again. Now it's... No, it's still 80. Okay, so is it because it has too much granularity? Wait, it was 7E. And now it's 80. So is it just adding? Is there an offset involved? Now it's 8. Yes. Now it's 9. Yeah, it is like just adding, isn't it? Line 2. Yeah. Okay. So why? Where does the offset come from? Well, okay. At least now we know it's a frame buffer. Obviously, it's the surface. So now it's just that it's compressed. Now, of course, the thing is we don't necessarily care about how the compression works, although it'd be nice to find out. So let's set this back to 0. And I'm going to mess around a bit more with the compression, see if I can like guess reverse engineer some of it. But 1 second. I just realized something. I just realized something. I just realized something. No DAPF on this one? I guess not. Because it could have totally been that. That's the cache. Huh? Yeah. That's fine. 1 F8. Oh. The hell is that? 23130040. 40, so it's 58. No. 30058. Is that writable? It is. No, it's not. Is that just I can reboot that. It still crashed. Am I not mapping anything that time? No. That is suspicious. That is suspicious. Is that a general thing where there's just an offset for the darts in some devices? Let me just reboot that. Okay, so hold on a second. Dart adder, this dart adder is right before that, and nothing there. Okay, that's the DAPF for the controller dart. Okay, that doesn't work though. Oh, it's there. Yeah, that's dead. It's an 8E there. That's the address we were reading. Okay, so let's go back to the hypervisor and see if I can dump a frame buffer. Actually, I want to look at, before I do that, uh, did my console just crash? Is it like trying to render some kind of insane character or something?